Good afternoon and Happy New Year. I'm Ann Aylward, Director of the USDOT Volpe National Transportation Systems Center, and it's great to see so many of you back for the second half of our Thought Leadership series, Up, Up and Away, Innovations in Advanced Air Mobility. This is the fourth event in the jointly sponsored Volpe Center FAA series, and today's session is focused on environmentally responsible advanced air mobility. We have a great group of speakers this afternoon. I'm pleased to welcome Julie Marks, Acting Executive Director in FAA's Office of Environment and Energy, Dr. Stephen Rizzi, Senior Researcher for Aeroacoustics at the NASA Langley Research Center, and Christopher Ruth, Chief of the Environmental Measurement and Modeling Division at the Volpe Center. We had a great session right before the end of the year featuring Paul Fontaine and Steve Bradford from FAA and Bob Pierce from NASA, who spoke on urban air mobility concept of operations and one of the strategic goals of USDOT transformation. We have just posted the recap, so if you missed the session, I encourage you to check it out on the Volpe Center website. I'm now pleased to welcome Julie Marks to deliver opening remarks. As Acting Executive Director in FAA's Office of Environment and Energy, Julie Marks leads the development of aviation, environmental and energy policies, goals, and priorities, and oversees research, engineering, and development projects and initiatives. Most recently, she served as the Deputy Director of the Safety and Integration Division in the UAS Integration Office, collaborating across the FAA and with industry to facilitate solutions to advance UAS operations and integration efforts. Welcome, Julie. The floor is yours.
Thank you, Anne. Hello, everybody. And thank you so much for the introduction and for hosting this Thought Leadership series. It's really an honor and pleasure to be here today and give some introductory remarks. I hope they provide some useful context for this session. As we prepare for new entrants such as AAM aircraft, we must really understand the environmental impacts and the community concerns and take steps to minimize and address them. As with traditional aircraft and other new entrants like drones, there are multiple aspects to be considered with AAM. For example, we need to consider the different types of environmental impacts, which could be noise or visual impacts. We must consider the aircraft itself, how and where the aircraft is operated, and consider the different stakeholders and their individual roles. So facilitating environmental responsible AM is an important topic. It's one that me and my team at FAA's Office of Environment and Energy, as well as others at FAA are working, including through such efforts as FAA's Innovate 28 effort. However, while the FAA can have an important role in facilitating environmentally responsible AAM operations, other stakeholders have important roles as well. For example, NASA, aircraft manufacturers, AAM vehicle operators, the vertiport operators, and importantly, both the state, local, and tribal entities and the communities themselves. So today you're going to hear from two speakers about their roles in facilitating environmentally responsible AAM. Touching for a moment on FAA's environmental responsibilities, one area we have a role is in certificating the aircraft. And any aircraft certified for airworthiness in the US must also comply with noise standard requirements to receive noise certification. FAA is also responsible for conducting environmental review of certain FAA actions and for engaging with communities related to AAM for those FAA actions. However, it's important to note that it's likely that only a subset of AAM actions will require FAA environmental review. An example of an action that would trigger an FAA environmental review is a proposed vertiport on a federally funded airport. This would trigger an airport layout plan change, environmental review, and airspace analysis. Another example would be if a project would require development or changes to air traffic procedures. So in these situations where there is an FAA approval that's triggering an environmental review, then we would do the environmental review, complying with federal environmental review requirements, and do community engagement in collaboration with the relevant stakeholders. However, we expect that a large swath of the AAM operations will occur in situations where an FAA environmental review is not triggered. An example would be a proposed vertiport that is not co-located on a federally funded airport. So in this case, this would trigger FAA's notification and airspace analysis requirements and get an airspace determination, but it wouldn't trigger NEPA. In these cases, there's no environmental review or community engagement from an FAA action for that proposed A action. So in those cases, once a state, local, or tribal entity decides they would like to have AAM operations, then they, along with the vertiport operator, the AAM vehicle operator, would then take responsibility for any environmental considerations and community engagement. They would also be the primary contact with the public regarding that proposed AAM operation. So that makes this session all the more important because we really must work together to understand AAM environmental impacts and community concerns. We must work together to take steps to minimize and address them so that we can ensure AAM is successfully integrated and in a way that the community supports. Today, we are fortunate to have two experts talk more about several important aspects that I just mentioned. First, we have Chris Ruve, and so he's going to talk about Volpe's support in multiple different areas. For example, they're supporting AAM stakeholders in such areas as aircraft noise certification, the modeling of that noise, and environmental review. And then we have Steve Rizzi from NASA, who will talk about NASA's important work in advancing understanding of the aircraft source noise to estimating community impact. So they are doing some amazing work in collaboration with FAA and many others on this topic, and we're really fortunate to have them here with us today. With that, I will hand it back to Anne, who will formally introduce the first presenter, and thank you, and I hope you find the panel informative and helpful.
Thank you very much, Julie. As Julie said, it's now my pleasure to introduce Chris Ruth, Chief of the Environmental Management and Modeling Division at the Volpe Center. Chris has decades of technical experience, including measurement, modeling, and analysis of noise, fuel burn, and emissions for all modes of transportation. He has helped lead the development of aviation environmental tools, including the Aviation Environmental Design Tool for the FAA Office of Environment and Energy, a model that enables analysis of noise, fuel burn, and emission interdependencies at multiple levels. He also helps FAA coordinate research efforts, including those that support environmental tools. Chris has also partnered with NASA, conducting measurement programs designed to develop and improve algorithms, as well as add new aircraft to model databases and inform regulations. He has authored numerous peer-reviewed journal articles and been involved in the development of international standards and regulations on transportation-related environmental issues, and has been an invited speaker at a wide range of transportation-related environmental conferences and workshops. Chris, we look forward to hearing from you today. Thank you.
Thanks, Anne. And I could just get a quick audio check and make sure that I'm presenting the full screen slide.
Yep.
Great. Well, thank you, Anne and Julie. It's a pleasure to be here speaking with you today. And I'm going to talk briefly about the Volpe Center's role, particularly in acoustics, with environmentally responsible integration of advanced air mobility vehicles, or AAM. So the few things I'm going to talk about today are noise certification of AAM vehicles, noise modeling in support of environmental review, in particular the National Environmental Protection Act, or NEPA, for AAM, the crucial aspects of intergovernmental coordination and support, and then some technical support that we've provided here at the Volpe Center directly to AAM industry partners. So first, I'd like to talk a little bit about our support over the years for a number of emerging technologies in aviation, and I think it'll set the stage for AAM in particular. So starting in the 1970s, we conducted the first noise measurements of the Concorde in Alaska prior to its being allowed to fly into the National Airspace System. Later in the 70s, we also followed that up with secondary boom measurements of the Concorde in the northeastern United States. Interestingly, recently, in support of NASA's X-59 flight test program, we've actually literally pulled data from the 1970s off of tapes to analyze aspects of sonic booms. In the 1980s, we conducted a series of helicopter noise measurements. Those have since become known as the Rainbow Reports. They provided a solid technical foundation for noise modeling and noise analysis techniques for decades to come. They also formed the foundation of the heliport noise model, the original FAA helicopter noise prediction tool, then the AAM, the integrated noise model, and now ADT. In support of FAA, we also conducted measurements of the unducted fan with NASA. And interestingly, some of the data from that project now are supporting the open rotor concepts being investigated by manufacturers. In the 1990s, we conducted flight test measurements side by side with McDonnell Douglas, NASA, and FAA of the MD-600N no-tail rotor or NOTAR helicopter. This was important as it was a new technology at the time, and we needed to understand the potential implications of that technology on noise certification. We also spent a fair amount of time in a very muddy portion of Texas doing flight tests and noise measurements of the X-15 tilt rotor helicopter. Moving into the 2000s, we've conducted a number of measurement campaigns of small drones or unmanned aerial vehicles. Those have included both standard noise certification like measurements with either 4-foot microphones or ground plane microphones, as well as larger scale array measurements to understand the directivity characteristics of these vehicles. We also worked with one manufacturer on measurements of a spiroid winglet installation on an aircraft. In this case, we did pre and post installation. You can see the picture down here in the lower center. The technology was originally proposed specifically for fuel burn and emissions benefits, but as one could imagine, essentially flying a tube at the end of a wing on an aircraft could potentially have some acoustic considerations. We've also worked closely with a number of partners on UAM and AAM measurements and analyses. We'll talk a little bit more about that in the future slides. And in support of FAA, participated in NASA's GoFly measurement. So noise certification has been around for many years with a lot of engagement from our traditional commercial aviation manufacturers, the Boeings and the Airbuses of the world, and as well as the smaller aircraft manufacturers. There are separate processes for both fixed wing and rotorcraft. These include the instrumentation used, the analysis techniques, even the metrics that are ultimately developed. Similarly, there are separate processes for small and large rotorcraft. The technical issues that are investigated for these noise certifications include background noise, signal to noise ratio, ground effects, terrain, instrumentation, and many other aspects. Over on the right, you'll see a table assembled in a Urban Air Mobility Noise Working Group, or UNWIG, document led by Dr. Rizzi. And that highlights a number of the references and standards from the traditional noise certification world, which may inform noise certification for UAVs. So there are a number of novel technical issues that may be considered as a part of noise certification of new and emerging vehicles. Thankfully, FAA, through its Ascent program and otherwise, has invested in a number of these aspects. So in the upper right, you'll see a picture from a Penn State project, Ascent Project 77, looking at wind speeds directly on the vehicle. Now, this is an unmanned aerial vehicle, in this case, much smaller technology, but these types of concepts may very well be relevant to AAM vehicles as well. Others have been looking at the implications of individual phases, rotor phase, and the directivity of these vehicles. So moving forward, how do we treat advanced air mobility noise certification? I've already noted that it's not the legacy Boeings and Airbuses of the world. There are many players in this world, some new to the aviation sector and probably more to come in the future. The technologies themselves can be rapidly evolving at times. The missions of the vehicles themselves also can be quite different than a traditional rotorcraft or fixed-wing aircraft. Some of these vehicles, like a tilt rotor, may have transition states, which may need to be considered in the noise certification process. And what metrics truly are best for these vehicles? All these are being considered by FAA, NASA, industry partners, and a number of working groups, but they're all important for consideration. So in terms of characterizing these vehicles for noise certification, collaboration is an important aspect. FAA and NASA have long-standing relationships where NASA works the fundamental research issues, and then FAA uses that learning to sort of set up the regulatory frameworks for vehicles. In addition to the FAA-NASA relationship, other government entities are certainly engaged and actively now as EASA and the UK CAA, among others. But within ICAO, other industry and partners can be engaged as well. So within the FAA, there's an individual vehicle white paper process that's been undertaken. And with this for AAM, one can certainly certify a vehicle under the existing rules if warranted. Those are Appendix H and J of FAR 36 for large and small rotorcraft, or Appendix K for tilt rotors. But absent of the direct applicability of those specific existing procedures, a rule of particular applicability, or RPA, using a G3 paper, issue paper can be used. In parallel, there's also the international process being coordinated with ICAO, the International Civil Aviation Organization. Now, echoing some of the comments that Julie made earlier, I want to talk a little bit about noise modeling and its use and support of environmental analysis in general and NEPA in particular. But I want to take this quote directly from FAA's AAM implementation plan, and that being, in order to determine whether compliance with NEPA is required, the FAA will need to identify whether there is or are a major federal action or actions triggering NEPA. So clearly, like Julie said, if it's on an commercial airport with a federal action, NEPA would be triggered. If there are other things that may trigger NEPA, then that process will be invoked. But there are certainly many opportunities for vertiports and AAM operations where NEPA may not be triggered. In this case, like we're talking about here, noise is an important consideration, but emissions also may be a consideration. Community engagement is also always a very important aspect of the environmental process. And I want to bring your attention to the graphic in the center of the slide. This is one of our Fly Neighborly training sessions that we conducted at an industry forum over the years. And in this case, it was to outreach to one aspect of the community, that being the pilots for helicopters, and train them and work with them to understand how to fly neighborly or fly with consideration of the noise on the communities around them. This is one aspect of community outreach and may be useful with the integration of AAM as well. Obviously, if there are infrastructure improvements required, construction impacts will need to be looked at. And as always, environmental justice and wildlife considerations are important. So in terms of modeling, there are a number of tools at our disposal to look at advanced air mobility vehicles. The FAA's Aviation Environmental Design Tool, or AEDT, is the de facto standard worldwide. It's required for use around commercial airports in the US. It's a robust tool with thousands of users and has a lot of capabilities to bring to bear. The Advanced Acoustic Model is another model available. It's a noise simulation tool. And is helpful in understanding very specific nuances of vehicles, including AAMs. Additionally, FAA is invested in other tools through its Ascent Center of Excellence research projects. MIT and Georgia Tech have two tools that certainly inform this process overall. Intergovernmental coordination and support is key. Over the last several years, we've worked directly with both NASA Ames and NASA Langley to understand use of the AEDT as it pertains to AAM. So with NASA Ames, we undertook a model evaluation both of ADT, the Advanced Acoustic Model, and Air Noise UAM. That was documented in a paper by Steve and some of his colleagues. And we also looked at the ADT capabilities and limitations specific to AAM, including EJ and specific vehicle characteristics. With Steve and his team at NASA Langley, we looked at unique approaches to modeling, whether defining aircraft as rotorcraft or fixed wing within ADT. We looked at understanding the use of fixed point versus procedural profile models, and helped them understand the best way or unique ways to bring bulk operations into the tool. Again, outreach and coordination was an aspect of that support. So speaking of outreach and coordination, given the airport-centric nature of commercial aviation over the last several decades, there is a procedures in place to reach out to either the noise ombudsman and FAA or your local airport noise office if you have a complaint or an issue with aviation noise. Thinking that to operations not specifically focused on commercial airports, what is the protocol for people to do? Is it to call your town hall, look at the logo on that AAM vehicle flying overhead and call that commercial entity, or reach out to your local police? These types of things will need to be addressed moving forward to make sure that everybody's on the same page and we can engage the communities as effectively as possible. So I want to talk briefly about some technical support that the Volpe Center provided directly for the AAM industry. In particular, we conducted an audibility or D-prime analysis using the Advanced Acoustic Model. We leveraged multiple ambient environments directly from the Bureau of Transportation Statistics National Transportation Noise Map. And you see that in the upper right-hand side of the slide. I'm going to zoom in on that for you, and you'll see just what one region of the US looks like in greater detail. And as you can see, this map includes aviation, rail, and highway noise sources that were used as sort of surrogate ambience for the analysis of advanced air mobility vehicles. Additionally, we provided noise model improvements to the Advanced Acoustic Model directly for the industry. They came to us wanting for greater fidelity in the frequency domain. Previously, the model had 1/3 octave band capabilities, and we added in 1/12 octave band capabilities for their use. So I'll just give you a visualization of that support to industry. Looking at these four quadrants, the top two show traditional rotorcraft or helicopter. The bottom two, a notional eVTOL. On the right, there is the ambient that is used for this audibility analysis is a very quiet or nighttime ambient, versus on the left-hand side, a morning rush hour or more activity and louder ambient. So as you can see, there are differences in the audibility for these two vehicle types, as well as based on the different ambient that is used. So these are some of the kinds of tools that are available to help engage community members and work with industry and government alike. So with that, I'd like to thank you for your time. I do want to acknowledge a number of Volpe colleagues who have contributed to the technical foundations in this presentation, and some of them identified in parentheses have moved on to other organizations since Volpe, but all had strong contributions. Here are a handful of references for people, and I'll hand it back to Anne and maybe look at questions later.
Thank you very much, Chris. Excellent presentation. It was technical, but I actually understood it, so you hit the right mark. Our next presenter will be Dr. Stephen Rizzi, Senior Researcher for Aeroacoustics at NASA Langley Research Center. He leads a diverse research team focusing on developing revolutionary tools and methods for perception, influence, acoustic design of transformative air vehicles with application to all of NASA Aeronautics Research Mission Directorate programs. That sentence needs a breath in the middle of it. Steve has authored and co-authored more than 175 journal and conference publications and has received the NASA Exceptional Service Medal for sustained and exceptional contributions to the acoustics discipline. He's a fellow of the American Institute of Aeronautics and Astronautics, past chair of their Aeroacoustics Technical Committee and co-lead of the NASA Urban Air Mobility Noise Working Group. Before I turn it back to Steve, I'd just like to remind you that the Q&A box is available for your questions, and when Steve's presentation is completed, we will turn to those questions. So Steve, all yours.
Great. Can you hear me okay?
Yep.
All right. Well, thank you for that introduction and the invitation to speak today. And I just want to preface this by saying that although the talk is focused on urban air mobility, there are elements here that are applicable to other sectors in AAM, including small UAS for package delivery and regional air mobility. Next slide, please. So to assess community noise impact, you first have to know something about the source. And there are a couple of ways of determining that. One is through acoustic flight tests and another through predictions. Earlier in the webinar series, we heard from Eric Allison at Joby mention the 2021 acoustic flight test conducted by NASA and Joby on a pre-production prototype vehicle shown here on the slide. Flight test measurement campaigns like this can generate needed data, like that's shown in the lower right-hand side, but these are expensive to execute, and there are presently a limited number of opportunities to do so. So the remainder of this presentation focuses on the prediction side of the house and how those predictions may be used to help understand and mitigate community noise impact. Next slide, please. NASA has developed a tool chain for analysis of noise and performance of VTOL vehicles, including eVTOL. And I don't have the time to go into all the detail here, but the three main elements along the diagonal include a conceptual design tool called NDARC, a comprehensive analysis tool that's may be used for, two commercial codes may be used for that, CAMRAD 2 or CHARM, and then acoustic analysis using the NASA Aircraft Noise Prediction Program 2 or ANOP 2 and its rotor noise tool, AARON. Next slide, please. So NASA has developed a set of concept reference vehicles, that is paper airplanes, to help us understand the noise produced by different aircraft configurations. Two are shown here, the quad rotor on the left and the Lift Plus Cruise on the right, and other reference vehicles, including a tilt rotor, tilt duck, and side by side was shown on the title slide. Next slide, please. As we dig a little bit deeper now into the source noise prediction, but not too deep, the process results in what we call source noise hemispheres. Two of these are shown on the right for two of the dominant sources as periodic or tonal loading and thickness noise and broadband self noise. These source noise hemispheres reflect the strength and the distribution of the noise at different emission angles, and details of how the calculations are performed are shown on the left. Now, it's important to note that many eVTOL vehicles have redundant controls, which allow the vehicle to achieve the same flight condition, but in a number of different ways. And the noise can be significantly different in each of these control strategies. So optimizing the trim strategy for low noise is an area of active research. Next slide, please. So we can sit in front of our computers and generate a lot of data, but how do we know that that data are correct? To address that, NASA and others have conducted acoustic testing of isolated and installed propulsors to build an experimental database for noise prediction model validation. The top row shows some of the tests conducted on isolated propellers and rotors, and the bottom row shows some of the tests conducted on installed props and rotors. Next slide, please. These tests are performed at different scales and with different installation effects so that NASA and others in industry and academia may identify and remedy shortcomings that we find in our predictive models, since many of these models were developed for traditional rotorcraft operating under different flight conditions. Next slide, please. So now that we've got that under our belts, we can talk about the more interesting part, And that is, well, what do we do with these data? In the next series of slides, I'll take these on one by one. Noise certification, perception influence design, and oralization and psychoacoustics are directed at reduction of the noise at the source. This is one element of the ICAO balanced approach to aircraft noise management. Operational fleet noise assessments can be used to support land use planning and management, a second element of the balanced approach. And the acoustically aware flight control and acoustic flight simulator are directed towards noise abatement procedures, yet a third element of the balanced approach. Next slide, please. In the following, I'm not suggesting that noise certification be performed by analysis. I instead intend to show how analyses can be used during the design phase to assess noise measures that are used in certification. And as previously noted, but worth reiterating, NASA is not a regulatory agency within the United States federal government. Our role here is to perform research that may later be used to support future regulations by the FAA and other regulatory bodies. Next slide. So Chris covered this more or less. One thing I'll note is there are different standards and recommended practices, or SARPs. Those are shown in the middle bullet that may be applicable to UAM noise certification. And if you give it another click, please, you'll see an example of how the noise limit varies in the case of for the light helicopter category as a function of the weight. The NASA tool chain below, which we call the ANOP2 Mission Analysis Tool, or AMAT, takes those source noise hemispheres and flies them in simulation to calculate the noise metrics on the ground. So it's this tool chain then can be used to estimate those cert levels during design, that is before any metal is cut or fiber are laid. In addition, since many of the processes or standards require the vehicle be operating at the noisiest operating condition, and since there are multitudes of ways to fly, by running multiple analyses, it's possible to use the tool to help identify just what is the noisiest operating condition. And as an example, if you give another click, please, the estimated cert level for the quad rotor reference vehicle shown by the blue triangle is about 5 dBA less than a comparable weight common K1200 or K-Max vehicle. Next slide, please. So next is perception influence design. And the main idea here is to include human perception into the design of the vehicle beyond that captured by the cert metrics. I'll show an example of a single propeller just to demonstrate the approach. Next slide. And there's a lot here, and I don't have all the time to discuss this in detail. But what I would like to point out is that starting with the baseline propeller design, that's that C24ND in the top row, we can optimize the geometry of the blade shown in the copper 3 down below in the bottom row in a way that can significantly reduce the noise while maintaining the thrust. And you can see that by comparing the baseline data in the top row with the validation data in the bottom row. And an ongoing effort includes broadband noise in that optimization process and validation through acoustic wind tunnel testing. That's all well and good if we know what metric it is that we're trying to optimize on. Let's go to the next slide, please. But sometimes we don't know that, and we need to use a couple of other tools to better understand the human response. Those are oralization and psychoacoustics. Next slide. So it may be counterintuitive, but most of our analyses generate a number. For example, 60 dBA, but that tells you nothing about what it sounds like. Oralization can be used to turn our source noise predictions, again, those source noise hemispheres that we were talking about, into something that we can listen to. It can be used for community engagement, but here we're going to use it to generate test signals for psychoacoustic studies. And the NASA Oralization Framework, or NAF, has been developed for this purpose. Next slide. So in the last couple of years, we've performed 3 psychoacoustic tests in the NASA Langley Exterior Effects Room shown on the right. This is a psychoacoustic laboratory with spatial audio that simulates various flight operations. So in the first test of UAM sound quality, the objective was to investigate how annoyance varies with sound quality. So that's like things like how tonal or impulsive is the sound. The main finding there was that UAM sounds are more annoying than a reference sound played at the same level. That is to say that loudness is not the only factor affecting the annoyance. The next one, on noise and numbers, investigated how the annoyance varies with the number of operations and spacing between those operations. The main finding there was that the scenarios having the same average sound level over some period of time, we used about 4 or 5 minutes, do not produce equal annoyance. That means that the number of events also affect the annoyance. In the last test, in the EER, we investigated how the annoyance varies in the presence of a masking noise, for example, a city soundscape. And the main finding there was that most subjects have to first notice the sound, which is well above their detection thresholds before they become annoyed. Now, the EER is a very capable laboratory, but we're only able to test in our area. So to address that limitation, we developed a remote psychoacoustic test platform that allows us to test subjects anywhere in the world over the internet. In our first study conducted a year ago, that was aimed primarily at verifying the consistency of the results with prior results that we measured in the EER, and which we did to a large degree, giving us confidence in this coming year to use anonymized UAM recordings and oralizations to determine differences in annoyance between response of different aircraft, their operations, be it takeoff or landing, and other situational factors. Next slide, please. The operational fleet noise assessments can be used to support land use planning and environmental analyses. Next slide. Chris spoke about how the FAA Aviation Environmental Design Tool is used when NEPA is required. And NASA and FAA work together to figure out how to apply ADT to the analysis of UAM vehicle operations. Starting in the upper right-hand corner, we performed simulations of reference vehicle operations to identify routes, trajectories, and flight conditions. Shown here is a scenario around the Dallas-Fort Worth area having thousands of daily operations between about 46 vertiports. From that simulation data, we can use the tool chain now in the lower right to predict source noise data, those hemispheres, for a range of operating conditions over the full flight envelope. We next generate what's referred to as noise power distance data through simulation using that AMAT tool that I described earlier. NPD data are required inputs into ADT. And then finally, in the upper left, noise exposure maps expressed in terms of the average day-night level can be generated using ADT. And so a tool like this might help, for example, identify sighting of vertiports and their impact. Next slide, please. The acoustically aware vehicle application and the acoustic flight simulator are 2 applications that are geared toward how we might operate the vehicle to minimize the noise footprint on the ground. Next slide. So in the first, the acoustically aware flight control, this automatically changes the vehicle trajectory and the operating condition to minimize the noise at some noise-sensitive area, for example, a school. In the simulation, you can go ahead and click on that. A noise constraint of 60 dB is imposed. For the case on the left, the straight line route exceeds the limit at both observers, that small pink dot, and then the larger building. And then for the case on the right, if you maybe do it again, the vehicle changes its trajectory and the operating condition to meet that constraint. And this can be performed dynamically. So if something pops up like another aircraft, the control can change on the fly. The researchers who are involved in this effort are looking for opportunities to test this control in flight. Next slide, please. The last application is an acoustic flight simulator that may be used, as Chris indicated, to train pilots how to fly neighborly. That is, fly the route in such a way that it reduces the noise footprint on the ground. Next slide, please. So on the left side of this chart, the simulator is used to generate helicopter noise footprints in response to real-time inputs from a pilot. This capability was developed to support the FAA Fly Neighborly program. If you click on that graphic on the left in the middle, the movie will show how the A-weighted sound pressure level contours change as a result of the pilot input. Now, we don't quite have the real-time capability for UAM yet, as is on the left-hand side. However, what we can do is to record and replay various low noise operations to guide us or point us in the right direction. Next slide, please. So to summarize, a NASA prediction tool chain has been developed and validated, and improvements continue to be made in that. With these tools, NASA is in a good position to assist stakeholders reduce UAM community noise impact by helping to reduce noise at the source, by providing tools to support land use planning and environmental analyses, and by identifying noise abatement procedures. 3 elements of the ICAO balanced approach. Next slide. And with that, I thank you and acknowledge the support of the NASA program supporting this effort.
Thank you for a very interesting presentation, Steve. A lot of really good material here. We have some very good questions. Before I get to the technical questions, a couple of you have asked whether the PowerPoint slides are available. As I said at the outset of the program, we will post a recap of the session. Typically, we do not make the speaker's slides available, but if you're interested in pursuing that, please let us know and we'll forward your request to the speakers and let you have that dialogue directly. So first question is for Julie, but I think probably for any of you came up during her comments. So Julie, regarding your remarks related to how a lot of AAM projects won't require a federal environmental review, is this something that the industry is happy about? It seems like it's inviting them to have to meet 50 different standards, one for each state, instead of having a single federal standard for such a review.
Thanks, Anne. And thank you for the question. It's a great question. I can't speak on behalf of industry and how they feel. But I can say that from an FAA perspective, we do share publicly on our website all of our guidance and procedures for conducting environmental reviews when an FAA environmental review is required. So it has there our environmental review procedures, it has our community outreach guidance manuals, and those are public so that everybody has access to them. They can serve as a guide and a resource to both communities and operators, vertiport operators, et cetera, in order to facilitate quality and consistency across the country.
So this is a question targeted to Chris, but again, any of you feel free to answer. So in situations where NEPA is not invoked, what federal processes are relevant and available to ensure environmentally responsible facilities and operations?
I'm happy to defer to Julie if she likes on that one. I'll answer that from a technical perspective. I mean, NEPA is a great umbrella series of considerations and processes. So whether you have to invoke NEPA formally or not, you can still follow that process, right? It's great guidance on how to look at all the considerations. Now, that's different than a policy perspective specific to NEPA.
Right. And Chris, I think that's a great answer. I think just reiterating it, NEPA is when there's a federal action. So if there is not a federal action, we don't have an official process, but again, we would, our tools, our guidance, our procedures Our processes, as is asked, what processes are relevant? So there are the federal processes and procedures and documents and guidance are all out there. And those may not be able to ensure environmentally responsible facilities and operations when there's an NFA role, but they can certainly help hopefully guide and facilitate. And of course, we do get questions, and if there was not a federal action and there was somebody looking to get some guidance, they can always reach out to us, reach out to Chris, and get some guidance as well.
So this theme about local government seems to be a pervasive one. So just a couple more in that area. So at this point, what should state and local governments, planning and operating authorities be doing to prepare for the coming of AAM operations and their community impacts? Julie, I'm afraid that one may go back to you too. I'm sorry.
Hey, no, that's okay. I think it's because, so as we talked about, I talked a little bit in my remarks. I think first of all is understanding roles and responsibilities. I think it's really important for communities, for operators, for airport, vertiport operators to understand kind of their role versus the FAA's role, because you don't know that maybe you have a responsibility sometimes. So I think it's really important that everybody kind of understand everybody's responsibilities and where the authorities lie. And then, certainly I think if a community is, has elected officials, they should be talking to their constituents. Their constituents should be paying attention. I know that's hard sometimes, and really making sure they're aware and feeding into the process, and looking for that publicly available information and leveraging it where possible, and really just working together and reaching out and working with the community. You want to find ways that the community will, I think I'm going to call it, support in some way whatever is being proposed, so that it will be successful and will hopefully fulfill a community need that they find helpful.
Thank you. That's helpful. So question for Chris, and maybe also for, for Steve, and maybe also for Chris. Sorry, Chris, that's the second time I've called you Steve. I'm not sure what's going on here. So the questioner says, thank you for a very interesting presentation. I would like to know whether AADT is considered the industry standard prediction tool for heliports only. I do understand that Europe has started using a software called NOAA to predict noise from helipads, but they still use AADT for fixed wing aircraft noise prediction. And then secondly, with regard to AADT for ground noise modeling in major airports, such as taxiing aircraft, et cetera, is AADT considered the best available tool? Are there any other approaches used in the US, or is this usually not considered in a noise impact assessment?
I think you had it right in calling Chris Steve, and I'll let Chris answer that question and I can chime in.
And I've definitely been called worse. No, I mean, I guess, so a couple things. ADT is wholly capable of predicting fixed wing, commercial aviation, noise, and fuel burn and emissions for that matter, as well as rotorcraft. It has all the legacy capabilities for predicting helicopters. Like I mentioned during my discussion, there are other tools available for a number of things, the advanced acoustics model. So that's a simulation capability. It's different than ADT, which is an integrated model. So both are applicable at different times and useful in different scenarios. NOAA, I believe, and I'm not super familiar with NOAA, some of my colleagues here at Volpe are, I believe that's another simulation tool. So yes, any or all of the above, but I would stick with ADT, especially if you're trying to integrate, the fixed wing aircraft predictions with the rotorcraft or the AAM. So I mean, there's always all different kinds of considerations, and if you're looking at fuel burn and emissions along with noise. The other thing I'll just say, FAA has tons of items on its work plan for ADT. And amongst those are significant improvements to some of the ground operations and noise predictions. They're already well documented, the procedures are well developed, but like I said, FAA prioritizes those updates because there are many, many updates to be made to the models.
So Matt Friedman has offered that, this is not a question, just a sharing of information. In California, land use decision-making is a local topic. I think that's true pretty generally. Zoning and land use permitting is an important topic. The American Planning Association and NASA have published material regarding planning for vertiports. So those of you interested in the local planning issues might want to look for that document. And then more broadly describing environmental impacts, questioner says this is outside noise issues, but in regard to NEPA, has there been discussion of potential visual pollution impacts related to the high volume, small drone cargo delivery activity that people anticipate?
That's outside of my expertise.
Okay, seems like a topic worth keeping in mind. Let's see, I think we have time for one more question. Zoom has not yet quite managed this technology, I would observe. Yeah, another local government question. Is there much participation of local governments during the testing in reference to noise and also just the appearance, or is this testing closed course testing?
Maybe I can try to address that one. So there are tests to support gaining scientific information so that we can generate data that we need, either whether it be for certification or for research purposes. Those are usually, I would say, closed door testing, where we want to go in a quiet place and isolate and get the best data possible. And then the NASA and the FAA are working towards a plan to do community testing once these aircraft are fielded, and that would be very much a public endeavor. And this is early in the formulation, but it could be very well at early entrance communities where there are early entrants into service. Might be we might want to conduct surveys in those areas at some point in the future, not tomorrow.
So one more question, I think, and this may be coming at you again, Julie. Is there any current FAA guidance or policy on how to conduct NEPA noise analysis for passenger carrying UAM, given the currently limited noise data available for those vehicles? Is there any currently available noise data considered acceptable for use in NEPA noise analysis? Or maybe you, Chris.
Well, I mean, I would go back to some of the research work that Steve and NASA has done with industry. And I think, that, like he said, some of this stuff is done for research purposes to inform the modeling and the analysis techniques. So it is sort of, I won't say closed door, but it's, there are agreements made with the manufacturers because there are competitive issues at stake too. So I don't know of any specifically out there that are off the shelf that can be used by anybody anywhere, but there are notional representations that exist.
And thanks for this great question. Sorry, I was finding the unmute button. So first of all, our NEPA policy, guidance and policy is broad. And so it will generally apply even for analyzing UAM. With NEPA analyses, we use the best available data. So that's what we would do in this situation. So we are using all available data and developing appropriate methodologies as needed to tailor for these types of situations. So I think, some of it we can leverage what's existing, and there are some areas where we're working to refine those and tailor them to this unique, somewhat unique operating aircraft.
That's really helpful. Thank you. I mean, what I'm hearing in summary, and I think you put it very clearly, Julie, is that it takes a federal action to trigger NEPA. But that within the NEPA review and processes, there are useful processes that can be used outside NEPA. They're useful analytic tools. And what I'm hearing in the questions from the audience is concern that to the extent possible, there be some uniformity in those non-NEPA reviews, so that we don't have some of the fragmentation that we've seen. This is my interpretation.
Yes.
Fragmentation that we've seen in the surface transportation automated vehicle movements. So I think a continuing dialogue is really important. So thank you for all for being available today. This has been a really useful session and a great start for the new year. Our next session will be next Tuesday, January 23rd, also at 1 o'clock Eastern Time. The focus of the program will be equity considerations in advanced air mobility. Joining us will be Yolanda Wolf, Executive Director and Co-founder of Community Air Mobility Initiative, or CAMI, and Okioma Moronu, Legal Counsel for Zipline. So I look forward to seeing you there. As I said at the beginning, if please, even if you're not available Tuesday at 1, if you're interested in the topic, please feel free to register and listen to the session at a later date. So thank you all, and have a great afternoon. Those of you in the Northeast, stay warm. And thanks again to our speakers.